On September 27, 2024, a special telescope system in Hawaii called ATLAS spotted something new in the sky. It was a faint, fuzzy patch of light that wasn't there before. This system, whose full name is the Asteroid Terrestrial Impact Last Alert System, is designed to scan the heavens every single night, looking for anything that might be moving. And on that clear Friday in September, it found something special. Scientists quickly figured out it was a comet, and they gave it the official name C2024 S1 Atlas. But because it was going to be brightest around Halloween, many people started calling it the Halloween Devil Comet. Now, this name might sound a little scary, but there's nothing to be afraid of. In fact, its arrival is a wonderful opportunity for all of us to learn something amazing about our solar system. So, what exactly is this visitor? Where did it come from? And what will happen as it gets closer and closer to our Sun? These are the questions that astronomers around the world are asking, and we were going to explore them together. So, get comfortable and let S go on a journey to meet our cosmic visitor, C2024 S1 Atlas. First things first, let's talk about what a comet actually is. Have you ever made a snowman? Imagine that snowman, but instead of being clean, white snow, it's mixed with dirt, sand, and little bits of gravel. Now, imagine that dirty snowball is flying through space, all by itself, in the cold, dark emptiness far from the Sun. That, in a very simple way, is what the heart of a comet is. Scientists call this heart the nucleus. It's the solid, central part of the comet. The nucleus of C2024 S1 Atlas is probably only a few kilometers across, which is about the size of a small city or a big mountain. That might sound big, but in space that's actually pretty tiny. The nucleus is made of some of the original ingredients from when our solar system was born, about 4.5 billion years ago. Think of it as a cosmic recipe. The ingredients are frozen water, which we know as ice, but also other frozen gases like carbon dioxide and carbon monoxide. Mixed in with all the ice are dust, rocks, and organic molecules. Organic molecules are the building blocks of life, so in a way, comets carry the seeds of life. For billions of years, this dirty snowball, the nucleus of our comet, has been drifting in the deep freeze at the very edge of our solar system. It's been cold and dark and quiet, but now its long journey is bringing it closer to the warmth of our Sun, and that's when the magic starts to happen. As a comet gets closer to the Sun, something incredible begins. The Sun's energy, like a giant space heater, starts to warm up the icy nucleus. The ice on the surface doesn't just melt into a liquid. In the vacuum of space, it does something even more interesting. It turns directly from a solid into a gas. This process is called sublimation. You might have seen something like this with dry ice, which is frozen carbon dioxide. It doesn't turn into a puddle, it just vanishes into a cloudy gas. The same thing happens on the comet. The ices turn into a giant glowing cloud of gas and dust that surrounds the nucleus. This huge fuzzy cloud is called the coma. The coma can be enormous, sometimes growing to be hundreds of thousands of kilometers across. That's even bigger than the planet Jupiter. So even though the comet's solid heart is tiny, its fuzzy atmosphere can become gigantic, making it visible to us here on Earth. But that's not all. The Sun does more than just warm the comet. It also pushes on it. The Sun is constantly blowing out a stream of tiny particles called the solar wind. It's like a gentle but steady breeze blowing out from the Sun in all directions. This solar wind, along with the pressure from sunlight itself, pushes against the gas and dust in the comet's coma. This pushing action creates the most famous and beautiful part of a comet, its tail. A comet's tail is not like a dog's tail. It doesn't wag behind it. Instead, the solar wind and sunlight always blow the material directly away from the Sun. This means that as the comet travels around the Sun, its tail always points outward, no matter which direction the comet is moving. So when the comet is moving away from the Sun, its tail actually streams out in front of it, like a banner leading the way. Now here's where it gets even more interesting. A comet actually has two tails. There is a dust tail and an ion tail. The dust tail is the easier one to understand. It's made of the little bits of dust and rock that get pushed away from the nucleus by the pressure of the sunlight. This dust tail is usually curved and slightly yellowish, because it's reflecting the Sun's light. It's like a trail of breadcrumbs showing the path the comet has taken. The other tail, the ion tail, is made of gas. When the Sun's energy hits the gas molecules in the coma, it makes them electrically charged. These charged particles, called ions, are then pushed very strongly by the solar wind. This creates a second tail, the ion tail, which is often very straight, narrow, and bluish in colour. The blue colour comes from glowing carbon monoxide ions. So, a comet can have two beautiful tails, one made of dust and one made of gas, both pointing away from the sun, creating a spectacular sight in our night sky. So we know what a comet is, but where did our specific visitor, C2024 S1 Atlas, come from? The answer is a very, very long way away. Scientists believe that long-period comets like this one come from a place called the Oort cloud. Now, you won't find the Oort cloud on a map of our solar system that shows the 8 planets. That's because it's incredibly far away. Picture our solar system. You have the sun in the middle, then the rocky planets like Earth and Mars, then the giant gas planets like Jupiter and Saturn. Way beyond all of them is the Kuiper Belt, which is home to Pluto and many other icy objects. But the Oort cloud is even farther than that. It's a gigantic spherical shell of trillions of icy objects that completely surrounds our solar system. It's like a giant fuzzy bubble of cosmic leftovers, stretching out almost a quarter of the way to the nearest star. For billions of years, the nucleus of our comet was just one of these trillions of objects, peacefully orbiting in the dark, cold depths of the Oort cloud. But sometimes, something happens to knock one of these objects out of its orbit. It could be the gravity of a passing star, or maybe just a slight nudge from another object in the cloud. Whatever the reason, our comet was given a push, sending it on a new, long journey. It began to fall, very slowly at first, toward the centre of our solar system, toward the sun. This journey has taken tens of thousands of years, maybe even longer. For all of human history, this comet has been travelling through the dark, getting closer and closer. And now, finally, it is arriving in the inner part of our solar system, where we can see it. It is a visitor from a time long before humans even existed, a messenger from the deepest, coldest, most distant part of our cosmic neighbourhood. This brings us to the main event in the comet's life. Perihelion, that's a fancy word that simply means its closest point to the sun. For C2024 S1 Atlas, this will happen around October 28, 2024. This is the most dramatic and dangerous time for a comet, especially for a sungrazer like this one. A sungrazer is a comet that passes extremely close to the sun. Think of it like walking right next to a giant roaring campfire. You're going to feel the heat. As the comet dives toward the sun, the heat and the gravity become immense. The sun's gravity pulls on the comet, trying to stretch it and tear it apart. At the same time, the intense heat causes the ices to sublimate at a furious rate, creating a gigantic coma and incredibly long tails. This is also when the comet is at its brightest and most beautiful, potentially visible to us here on Earth, even during the day if it gets bright enough. But this close encounter is also a huge risk. The intense heat and powerful gravity can be too much for a comet to handle. Many sungrazer comets don't survive their trip around the sun. They get so stretched and heated that they break apart into a swarm of smaller pieces, which then either burn up or continue orbiting as a trail of dust. Scientists are watching C2024 S1 Atlas very carefully to see if it will survive. Some scientists think it has a good chance and could become a spectacular sight in the sky. Others are more cautious, pointing out that it could break apart at any moment. It is a bit of a cosmic cliffhanger. We just have to wait and see what happens. This uncertainty is part of what makes watching comets so exciting. They are wild and unpredictable, and they remind us that space is a dynamic and ever-changing place. Now, let's talk about the name. Why is it called C2024 S1 Atlas? It sounds like a secret code, but it actually tells us a lot about the comet if you know how to read it. The C stands for comet. The 2024 is the year it was discovered. The S tells us that it was discovered in the second half of September. Astronomers divide the year into 24 half months, and each half month gets a letter. A is the first half of January, B is the second half of January, and so on. By the time we get to September, S is the letter for the second half of the month. The 1 means it was the first comet discovered in that half-month period, and finally, Atlas tells us who discovered it. As we mentioned, it was found by the Atlas telescope system in Hawaii, so the full name is like a little biography of the comet. Comet discovered in 2024 in the second half of September, the first one found by the Atlas survey. It's a system that helps astronomers keep track of all the new objects they find. The ATLAS project itself is pretty amazing. It's not just one telescope, but a system of telescopes. Its main job is to be a lookout. It scans the entire sky every night, looking for anything that is moving or changing. This is how it finds new comets and asteroids. But its most important job is to find any objects that might be on a collision course with Earth. These are called potentially hazardous objects, or PHOs. By finding them early, we can track them and see if they pose any risk. So far, ATLAS has been very successful, finding hundreds of asteroids and dozens of comets. It's our planetary defense system, always watching, always ready to give us an early warning. The discovery of C2024 S1 ATLAS is a great example of how this system is not just protecting us, but also helping us discover the wonders of our solar system. Observing a sun-grazer comet like C2024 S1 ATLAS is one of the biggest challenges in astronomy. It's like trying to watch a snowball melt right next to a huge bonfire. The sun is so bright that it makes it very difficult to see the faint comet next to it. That's why astronomers rely on special telescopes, both on the ground and in space. One of the most important tools we have is a spacecraft called the Solar and Heliospheric Observatory, or SOHO for short. SOHO is a joint project between NASA and the European Space Agency, and it has been watching the sun non-stop since 1995. SOHO has a special instrument called a coronagraph, which acts like an artificial eclipse. It has a little disk that blocks the sun's bright face, allowing us to see the much fainter atmosphere around the sun called the corona, and anything else that might be passing by. Because of this, SOHO is the undisputed champion of comet hunting, having discovered thousands of comets, most of them sun-grazers. SOHO, along with another NASA mission called STEREO, which has 2 spacecraft watching the sun from different angles, will give us our best views of C2024 S1 ATLAS as it makes its fiery loop around the sun. These space-based observatories can see the comet 24 hours a day, without having to worry about clouds or daylight. They will watch to see if the comet's nucleus stays intact or if it starts to break apart. They will measure how bright it gets and how long its tails grow. This data is incredibly valuable. It helps us understand the structure of comets. How strong are they? What are they made of? How do they react to the sun's intense heat and gravity? Each sun-grazer we observe helps us build a better picture of these amazing objects. This brings us to the big question from our title: are we ready? When we talk about a comet like this, what does being ready even mean? First, and most importantly, we're ready in the sense that this comet is not a danger to Earth. Scientists have carefully calculated its path, and they know for sure that it will not hit our planet. It will pass between the Earth and the Sun, but it will be a safe distance away, so we don't need to worry about any impact. Being ready also means being ready to study it, and in that sense, we are more ready than ever before. We have a global network of telescopes, both on the ground and in space, all working together to watch this event. We have the computing power to track its path perfectly and predict its movements. We have the scientific knowledge to understand what we are seeing. In the past, a bright comet would appear, and people would just marvel at it, often with fear. Today we can marvel at it with understanding and curiosity. But why do we spend so much time and effort studying these comets? What's the big deal? Well, as we mentioned earlier, comets are like time capsules. They are made of the exact same material that formed our solar system 4.5 billion years ago. The planets, including Earth, have changed a lot over that time. They have been heated up, volcanoes have erupted, water has evaporated, and they have been hit by other objects. But a comet in the Oort cloud has been frozen in a deep freeze for all that time. It's like a perfectly preserved sample from the birth of our solar system. By studying a comet, we are essentially studying our own origins. We can learn what the ingredients were that built the planets. We can learn where the water on Earth might have come from. Many scientists believe that comets and asteroids, like C2024 S1 ATLAS, may have delivered much of the water and the organic molecules to the early Earth, providing the essential ingredients for life to begin. So in a way, we're all made of stardust, and comets are the delivery trucks that brought that stardust to our world. So as we watch this comet's journey, we are not just looking at a fuzzy ball of ice. We are looking at our own history. We are looking at the building blocks of our world. Every observation, every picture, every measurement helps scientists piece together the puzzle of how we got here. It's a story that is written in light and ice, and it's unfolding right before our eyes. Researchers all over the world are sharing their data, working together to learn everything they can about this visitor. They are measuring the gases coming from it, studying the dust in its tail, and watching how it reacts to the sun. This is a global scientific effort, and it's a wonderful example of how humanity can work together to understand the universe. Now, you might be wondering, can I see this comet? This is a great question, and the answer is maybe. Seeing a comet is a special experience, but it can be tricky. The best time to look for C2024 S1 Atlas would be in the days leading up to and after its closest approach to the Sun, around late October. However, because it's a sun grazer, it will always appear very close to the Sun in our sky. This means it will be best visible just before sunrise or just after sunset, when the sky is not completely dark. You would need a very clear view of the horizon, away from any buildings or trees, and most importantly, you must be extremely careful. You should never look directly at the Sun, not even for a second, as it can cause permanent eye damage. The safest way to look for a comet near the Sun is with the help of experienced astronomers who have the right equipment, like binoculars or a telescope, and know exactly where to look. There are many astronomy websites and apps that can give you day-by-day updates on where to look and how bright the comet is expected to be. Even if you can't see it with your own eyes, you can still follow its journey online. NASA, the European Space Agency, and many astronomy groups post amazing pictures and videos from their telescopes. You can see the comet's coma grow and its tail stretch out for millions of kilometers. You can watch it as it makes its fiery loop around the Sun. It's a spectacular show, and thanks to the internet, everyone has a front row seat. So whether you see it in the sky or on a screen, take a moment to appreciate this amazing traveller. It has come from a place so far away we can barely imagine it, and it is putting on a show for us that has been billions of years in the making. Let's take a moment to recap what we've learned so far. We've met our visitor, C2024 S1 Atlas, a comet discovered in September 2024. We learned that a comet is like a dirty snowball, with a solid nucleus made of ice and rock. As it gets close to the Sun, the ice turns to gas, creating a giant fuzzy cloud called a coma and two beautiful tails that always point away from the Sun. We also learned that this comet comes from the Oort cloud, a distant shell of icy objects at the edge of our solar system, and that it is now on a dangerous and exciting journey around the Sun, an event called perihelion. And we know that scientists are watching it carefully, not because it's a threat, but because it's a priceless time capsule that can teach us about the very beginning of our solar system. The story of C2024 S1 Atlas is still being written. Will it survive its close, pass by the Sun and become a brilliant spectacle in our sky? Or will it break apart into a cloud of dust and ice? We don't know for sure. And that's part of the fun. Space is full of surprises, and comets are some of the most surprising of all. They remind us that the universe is not static and unchanging. It's a place of constant motion, creation and destruction. Every time a new comet is discovered, it's a chance to learn something new, to witness a natural wonder, and to feel a connection to the vast, beautiful cosmos we all call home. So, keep looking up. You never know what other amazing travellers are out there, just waiting to be discovered. The countdown to perihelion for our Halloween Devil comet is on, and we are lucky to be here to watch it happen. Now that we've explored a visitor from the edge of our solar system, let's talk about a visitor from a completely different star system. This is the story of Oumuamua, the very first object we have ever seen that came from outside our solar neighbourhood. Its name, Oumuamua, is a Hawaiian word that means a messenger from afar arriving first. And that is exactly what it was. Imagine you're sitting in your house and you see a leaf blow by your window. You'd assume it came from a tree in your yard, right? But what if you found out that leaf came from a forest hundreds of miles away? That would be amazing. That's what it was like for astronomers when they discovered Oumuamua. It was like finding a message in a bottle that had floated across an entire ocean. Oumuamua was first spotted on October 19, 2017, by the Pan-STARRS 1 telescope, which is another one of those special telescopes in Hawaii, just like Atlas. At first, the astronomers thought it was just another comet or asteroid from our own solar system. But as they watched it and calculated its path, they realized something was very, very strange. It was moving way too fast. It was traveling at such a high speed that it couldn't be held by the gravity of our Sun. It was just passing through. It had come from interstellar space, the vast empty space between the stars, and it was on its way back out. This was a historic discovery. For the first time ever, We had a real object from another solar system right here in our cosmic backyard. The strangeness didn't stop there. As scientists studied Oumuamua, they found that it was a very unusual object. First of all, it had a weird shape. Most asteroids we see are sort of roundish or potato-shaped. But Oumuamua seemed to be very long and thin. The best way to describe it is like a cigar or a pancake. It was probably about 400 meters long, which is longer than a football field, but only about 40 meters wide. This extreme shape was something we had never seen before in a space rock. It was tumbling through space end over end, which made its brightness change as it spun. It would get brighter when its long side faced us, and dimmer when its short side faced us. This blinking light is how astronomers figured out its strange shape. But the biggest mystery of Oumuamua was the way it moved. After it passed the sun and was heading back out into deep space, it started to speed up. It got a little push. Now, comets do this. When a comet's ice turns to gas, it acts like a tiny rocket engine, giving the comet a little boost. But when astronomers looked at Oumuamua with their most powerful telescopes, they couldn't see any coma. They couldn't see any gas or dust coming off it. It looked like a simple, dark red rock. So, if it wasn't a comet with a visible tail, what was pushing it? This is the question that made Oumuamua so famous and so mysterious. Scientists came up with a few different ideas to explain this strange push. One idea is that it was a hydrogen iceberg. This is a very cool idea. It suggests that Oumuamua was a big chunk of frozen hydrogen gas. Hydrogen ice is invisible to our telescopes, so we wouldn't be able to see it. And as it got close to the sun, the hydrogen ice would have turned into a gas, creating that invisible rocket-like push. The problem with this idea is that it's very hard to make a big iceberg of pure hydrogen in space, and it probably would have melted away long before it reached our solar system. Another idea is that it was just a very strange kind of asteroid that was releasing just a tiny amount of dust that we couldn't see. Or maybe it was a nitrogen iceberg, breaking off from a Pluto-like world in another solar system. Each of these ideas is possible, but none of them perfectly explains everything we saw. And of course, because Oumuamua was so strange, some people wondered if it could be something else. A very small number of researchers even suggested that maybe, just maybe, it could be a piece of alien technology. They thought its shape and its strange acceleration could be signs of a solar sail, a thin, lightweight sheet designed to catch sunlight and use it for propulsion. It's important to know that this is a very, very unlikely idea, and most scientists do not think it was an alien probe. But the fact that we couldn't explain it perfectly is what made it so fascinating. Unfortunately, we may never know for sure what Oumuamua was. It was moving so fast that it was only in our solar system for a short time. By the time we realized how special it was already on its way out, heading for the constellation Pegasus and the dark spaces between the stars. We didn't have time to send a spacecraft to catch up with it. It came, it surprised us, and it left, taking its secrets with it. But Oumuamua changed everything. It proved to us that interstellar objects are real, and they can visit us. Just a couple of years later, in 2019, we found a second one, an interstellar comet named 2I Borisov. So now we know that our solar system is not a closed island. It's part of a much bigger galactic neighborhood, and things are always passing by. Oumuamua was our first messenger from afar, a reminder of how much more there is to discover out there among the stars. While C2024 S1 Atlas is a new and exciting visitor, and Oumuamua was a complete surprise from another star, there is one comet that is the most famous of all. It's a celebrity in the world of comets, a cosmic visitor that people have been watching and wondering about for thousands of years. This is the story of Halley's Comet. Unlike long-period comets that take thousands or tens of thousands of years to orbit the Sun, Halley's Comet is a short-period comet. It comes back to visit us on a regular schedule, about every 76 years. This regularity is what has made it so famous and so important throughout human history. The story of Halley's Comet is really the story of our understanding of the universe. For centuries, people saw comets appear in the sky and they were terrified. They didn't know what they were. They thought they were signs of bad luck, like the death of a king or the coming of a war. They were mysterious, fiery swords that would appear without warning and then vanish again. Ancient Chinese, Greek, and Babylonian astronomers all recorded sightings of a bright comet, and we now know that many of these records were describing Halley's Comet. A famous scene on the Bayeux Tapestry, which tells the story of the Norman conquest of England in 1066, shows people pointing at a comet in the sky with fear. That comet was Halley's. For a long time, no one understood that these comets were the same object, returning over and over again. That changed in the 1700s, thanks to a brilliant scientist named Edmund Halley. Halley was a friend of Isaac Newton, and he used Newton's new laws of gravity and motion to study the paths of comets. He looked at records of bright comets that had been seen in 1531, 1607, and 1682. He calculated their paths and noticed something incredible. They were all very, very similar. He realized that these weren't three different comets. They were the same comet, following the same path around the Sun and returning to be seen from Earth about every 76 years. Halley predicted that the comet would return again in 1758. Sadly, he didn't live to see if he was right, but on Christmas night 1758, the comet appeared in the sky, just as he had predicted. It was a triumph of science, and from that moment on, the comet was named Halley's Comet in his honour. Halley's Comet's last visit was in 1986. Many people who are alive today can remember seeing it. It was a big event. Scientists were ready for it in a way they had never been before. For the first time, we were able to send spacecraft to visit it. The European Space Agency's Giotto spacecraft flew right through the comet's coma and took pictures of its nucleus. It was the first time we had ever seen the heart of a comet up close. The pictures were amazing. The nucleus wasn't a round snowball. It was a dark, lumpy, potato-shaped object, about 16 kilometers long and 8 kilometers wide. It was spewing jets of gas and dust from its surface like a cosmic volcano. This mission taught us so much about what comets are really like. Halley's Comet is now on its long journey back out to the far edge of the solar system. It won't return until the year 2061. So, if you saw it in 1986, you might get a second chance to see it. If you missed it, you'll have to wait a while. But its legacy is huge. It helped us prove that comets are not scary omens, but predictable objects that follow the laws of physics. It showed us that we can predict their paths and even send robots to visit them. It has a special connection to history. The famous American author Mark Twain was born in 1835 during a visit of Halley's Comet. He said, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." And he did. He passed away in 1910, the day after the comet made its closest pass by the Earth. Halley's Comet is more than just a ball of ice and rock. It's a timekeeper, a link between the past, the present, and the future, and a symbol of our never-ending quest to understand the cosmos. The question, "Are we ready?" in our main title isn't just about watching comets. It's also about understanding and potentially protecting ourselves from objects that could come a little too close for comfort. This brings us to the story of an asteroid named Bennu, and an incredible space mission called OSIRIS-REx. An asteroid is a bit like a comet, but with one big difference: it's mostly made of rock and metal, not ice. Bennu is a near-Earth asteroid, which means its orbit brings it relatively close to Earth. In fact, Bennu is considered a potentially hazardous asteroid. Now, before you worry, let's be clear. There is no threat from Bennu for a very, very long time. Scientists have calculated that it has a very small chance of hitting Earth in the late 2100s, but because of that small chance, it's a very important object to study. The OSIRIS-REx mission was designed to do just that, to get to know Bennu up close and personal. The story of OSIRIS-REx is a true space adventure. The spacecraft launched from Earth in 2016. It then began a long 2-year journey, travelling millions of kilometres to catch up with Bennu. When it finally arrived in 2018, it didn't just fly by. It went into orbit around the tiny asteroid, becoming the first spacecraft to orbit an object so small. Bennu is only about 500 metres across, which is tiny compared to a planet. For the next 2 years, OSIRIS-REx mapped Bennu's entire surface, studying its shape, its composition, and the way it moved. The pictures it sent back were breathtaking. Bennu wasn't a smooth, round rock. It was a rubble pile asteroid, shaped like a spinning top, and its surface was covered with giant boulders. It looked like a giant pile of gravel and rocks in space. The main goal of the mission was to do something that had never been done before, to travel to an asteroid, touch its surface, and collect a sample to bring back to Earth. This was an incredibly difficult task. The team on Earth spent over a year searching for the perfect place to land. They needed a spot that was clear of big boulders and had the right kind of fine material, like sand or dust, that they could collect, They finally chose a small spot inside a crater and named it Nightingale. Then, on October 20th, 2020, it was time for the big moment. The OSIRIS-REx spacecraft slowly descended toward the asteroid's surface. It extended a special robotic arm with a collection device on the end that looked a bit like an air filter. The whole process was automated, because it takes several minutes for a signal to travel from Earth to Bennu and back. The spacecraft had to do it all by itself. As the arm touched the surface, it puffed out a burst of pure nitrogen gas. This gas stirred up the dust and small rocks on the surface, which then flew up into the collection device. The whole touch-and-go maneuver only lasted for about 6 seconds. Then, the spacecraft fired its thrusters and backed away from the asteroid. It was a perfect touchdown. But the team got a surprise. When they looked at the pictures from the collection device, they saw that it had collected so much material that the flap was stuck open, and some of the precious asteroid dust was leaking back out into space. They'd collected way more than they ever expected. They quickly decided to stow the sample capsule immediately, without doing the planned measurements, to make sure they didn't lose any more of their treasure. The mission was a huge success. After saying goodbye to Bennu, OSIRIS-REx began its long journey home, carrying its precious cargo. In September 2023, after travelling for over 7 years and covering billions of kilometres, the spacecraft finally arrived back at Earth. It released a small capsule, which contained the sample from Bennu. The capsule entered Earth's atmosphere, parachuted down safely, and landed in the desert in Utah. Scientists rushed to the landing site to recover the capsule. When they opened it up in a special clean lab, they found that they had collected about 250 grams of asteroid material. That might not sound like a lot, but it's a treasure trove for scientists. This is the largest amount of material ever brought back from an asteroid. Now, scientists from all over the world are studying these tiny pieces of Bennu. They are looking for clues about how our solar system formed, and they are studying the water and organic molecules in the sample, which might tell us more about how life began on Earth. The OSIRIS-REx mission is a perfect example of how we are ready. We are ready to explore these objects, to study them up close, and to bring pieces of them back home. It shows that with clever engineering and a lot of hard work, we can turn a potential hazard into a scientific goldmine. The question, are we ready, is not just about watching comets or studying asteroids. It's also about understanding what happens when these objects hit planets. And for the most dramatic answer to that question, we have to go back to the year 1994 and tell the incredible story of Comet Shoemaker-Levy 9. This event was like something out of a science fiction movie, but it was real, and we watched it happen. It was the first time in human history that we saw a comet collide with a planet, and it gave us a powerful lesson about the dynamic and sometimes violent nature of our solar system. The story begins in March 1993. A team of astronomers, including the famous husband and wife duo Eugene and Carolyn Shoemaker, and their colleague David Levy, were using a telescope at Palomar Observatory in California. They were taking pictures of the sky, looking for new asteroids and comets. When they developed one of their photographs, they saw something strange. It looked like a comet, but it wasn't a single fuzzy blob. It was a string of fuzzy blobs, lined up in a row like pearls on a cosmic string. They had discovered a new comet, and it was like nothing anyone had ever seen before. As astronomers around the world pointed their telescopes at this strange object, they figured out what had happened. This comet, which became known as Shoemaker-Levy 9 or SL9 for short, had not always been in this shape. It had once been a normal comet, but a few years earlier in 1992, it had passed extremely close to Jupiter. Jupiter, the largest planet in our solar system, has a very powerful gravity. The gravity had been so strong that it had pulled the comet apart, tearing it into over 20 smaller pieces. These pieces were now all travelling together in a line, following the same orbit. And astronomers made another, even more startling discovery. They calculated the orbit of this string of comet pieces and found that it was on a direct collision course with Jupiter. The pieces were going to hit the planet in July 1994, just over a year away. This was a once-in-a-lifetime event. Astronomers were thrilled, but also a little nervous. They had a year to prepare. Every major telescope on Earth was booked to watch the event. NASA and other space agencies pointed the Hubble Space Telescope and the Galileo spacecraft, which was orbiting Jupiter at the time, toward the planet to get a front-row seat. No one knew exactly what to expect. Would the impacts be visible from Earth? How big would the explosions be? Would they leave a mark on the giant planet? The impacts began on July 16, 1984, and they continued for a week. One by one, the pieces of Comet Shoemaker-Levy 9, some of them a mile or two across, slammed into Jupiter's atmosphere at a speed of over 200,000 kilometers per hour. The explosions were enormous, far more powerful than any nuclear weapon ever created on Earth. The first impact hit on the side of Jupiter facing away from Earth, so we couldn't see it happen. But we knew it had occurred because the planet's rotation brought the impact site into view a few minutes later, and we could see a giant dark plume of material rising thousands of kilometers above, the cloud tops. It was a huge bruise-like scar in the planet's atmosphere. As the week went on, more and more pieces hit. Some of them struck on the side of Jupiter facing Earth, and telescopes on Earth actually saw the bright flash of the impact as the piece of the comet exploded in the atmosphere. It was an incredible sight. The Hubble Space Telescope took stunning pictures of the impact sites. They looked like a string of black eyes on the giant planet. The largest scars were bigger than the entire planet Earth. The explosions were so powerful that they created seismic waves that rippled all the way around Jupiter. The event was a planetary-scale catastrophe, but luckily for us, it was happening on another planet. The crash of Comet Shoemaker-Levy 9 taught us so many things. It was a real-world demonstration of the fact that comets and asteroids do hit planets, and that these impacts can have huge consequences. Before this, the idea of a cosmic impact was mostly theory. Now, we had seen it with our own eyes. It helped scientists understand the role that impacts might have played in the history of our own planet, including the impact that wiped out the dinosaurs 66 million years ago. It also showed us the important role that giant planets like Jupiter play in our solar system. Jupiter acts like a cosmic vacuum cleaner, its powerful gravity pulling in comets and asteroids that might otherwise be on a path to hit the inner planets, like Earth. In a way, Jupiter protects us. The Great Comet Crash of 1994 was a wake-up call. It showed us that space is not a quiet, empty place. It is a place of constant change and occasional violence. It made us realize how important it is to keep watching the sky, to find the objects that might be a threat, and to be ready. It's a key part of the answer to the question, are we ready? Seeing the scars on Jupiter reminded us that while the chances of a major impact on Earth in our lifetime are very small, they are not zero, and thanks to missions like OSIRIS-REx and telescopes like ATLAS, we are more ready than ever before to find these objects, study them, and hopefully protect our planet from them. The story of Shoemaker-Levy 9 is a powerful reminder of both the beauty and the danger of our cosmic neighborhood.